Assume commodity Q is produced by the production function here. Show that it's a CES production function, which is of constant elasticity of substitution production function. So we need to show that it's a CES. So what is the first thing that we need to do here? Well, is just to write the formula, which is given by differential of K over L over differential of MRTS multiplied by this here, MRTS, then this here, K over L right now. But this formula confuses a lot of people. So in this video, I want to show you a very simple trick just to change this formula to something that we are very familiar with. So we'll say write MRTS equal to X, then K over L equal to Y. So that we change this formula to something that we are very familiar with, dx, just replacing the variables that we have. Oh, sorry, we are supposed to write that is dy over dx. I'm just writing the variables that we have introduced. Then x will be here, and we'll have y down there. So this, at least we are very familiar with it. So let's first of all work with this. Then I'll show you where we are able to employ this to simplify our lives. So let's go on and find the MRTS because we have it in here. We also need to find this as well as everything that we have in the formula. So let's begin with the MRTS. So MRTS is given by marginal product of capital. So MRTS is given by marginal product of labor divided by marginal product of capital, where marginal product of labor is equal to the differential of production function with respect to labor. So we're going to differentiate the function that we have in here with respect to labor. So what we'll do is we'll employ the chain law. So we'll drop this power. We'll have 1 over P like that. And we'll have open brackets LP plus KP, just copying the things inside. Then the power will drop by 1. So we will have 1 over P minus 1 like that. So here we will have again, we have to differentiate this, the L inside. So when we differentiate it again by chain law, we will drop the P, which is the power, multiplied by L, and the P will drop by 1 like that. So this is our marginal product of labor. But we can also see that the P and the P cancels, so we just remain with open bracket LP plus K, P, 1 over P minus 1, multiplied by L, P minus 1 like that. So this is our reduced marginal product of labor. That is by cancelling that P. So we'll rewrite this formula, don't worry. I just want to create some space here so that we can utilize it. And just remove this, make it look a bit smart. So let's turn on to marginal product of capital, which we'll get through the same process, differentiating the production function with respect to K this time around. We'll be dropping again the same power, 1 over P multiplied by LP plus KP, close brackets, and the power reduces by 1, which will be like that. Then we differentiate this time around K because we're differentiating with respect to K. So we drop the power, then it will be K, the power reduces by 1 like that. You can also see even here that P is cancelling because this P is dividing everything here. So we can therefore say that we remain with L P plus K P, 1 over P minus 1 and K P minus 1 like that. So the second thing is to get the MRTS now. So we have the marginal product of labor here, so we can just divide these two. LP plus K P, these are in brackets, or we have again the power. So this power is not having a 1. So we have cross brackets and the power minus 1. Like that, multiplied by L P minus 1. Then divide by L P, P like that, close the brackets, 1 over P minus 1, and we'll have K P minus 1 like that. So if you notice, this term here and the down term here, they are the same. So we can cancel this one as well as that. And the only thing that will remain here is just L P minus 1 divided by K P minus 1 like that. So this is the MRTS, but we can reduce it further by simply saying this power and that power are common. So we can say we have L K, close the brackets, then P minus 1 like that. We just create some space here. So notice that we have MRTS is equal to 1 over K like that, then P minus 1. But in this formula, if you check, we don't have L over K. We have K over L. So we need to work on this. But how do we do that? So what we need to do is just to swap this. L goes down, the K goes up. But once we do that, we also need to swap this. It will be 1 over P minus 1. But this is just the same as writing negative P minus 1 like that. And when we multiply by the negative throughout here, the power will change to something like this. So we'll have K changed over L. Then the power will be negative multiplied by P. It will be negative P, then positive 1. So we'll start with the positive number, 1 minus P, like that. And again, the other thing that we need to notice is that in our formula we have K over L. So we need to make again this as the subject of the formula. So in short, this is MRTS we have found, but we want again to find this. So let's go on and find that. How do we do that? So we say MRTS is equal to K over L, then 1 minus P like that. So we want to get rid of this P. So we will have everything here multiplied by 1 over 1 minus P, the reciprocal of this. So that when we multiply, it cancels. Then even here, we're multiplying everything just by that. So let me create again space. So we can work from here. So here we will have that term and that will cancel. So we will just remain with K over L is equal to M RTS 1 over 1 minus P. Because this term is multiplying everything. So we also get that. So from here, instead of employing this formula, if you're okay, you can't get lost employing this formula, it's okay, you can do that. But in this video, I want to show you something very simple. So you need to rate this the y, then this the x, as we did, so that we have this formula changed to the y over the x, multiplied by x over y, like that. So this expression here, when we write it in terms of the variables that we have just introduced, it will be y is equal to x 1 1 minus b, like that. So getting the y over the x from here will just be the y over the x will be dropping the power because we are using the chain rule. We drop the power, then we'll have x, then the power reduces by 1. We'll have 1 minus b minus 1, like that. So this is going to be replaced in this. So we will have 1 minus b x 1 minus b minus 1 multiplied by this x in the formula, like that, over this y. But we want everything to be in terms of x so that it becomes very easy for us to compute this. So what is y? So y is this term here. So we replace y by that term in x. So we'll say y, which is just x, 1, 1 minus b, like that. So we go on with the computation. Let me write from the other side. We don't need to change anything there. We just need to use these some things. So what we need to do here, we also love this, so that I put it this way. Let me just rewrite the constant first of all, which is 1, 1 minus b, then x, 1 minus b like that. So I've just written that. If you notice from here, this x is common with that. And when we have two things common, multiplying, we had the powers. So this x has a power 1, which I just wrote here. So this power, when we add to this, we will cancel with that power. And what will remain is just that term. Then we multiply by 1 over the x, 1 minus b like that. And again, the other thing that we can notice is that this term here and that term, they're just the same. So we can cancel them. So we are going just to remain with 1, 1 minus b like that. And this is our final answer. So we can show that, we can therefore say that this is a CES production function because in here we don't have L or capital, which is K. Therefore, it shows us that it's a constant elasticity of substitution production function. Let's go on and work on question 2. This time around, we assume that commodity Q is produced by the production function of this form. And once again, we want to show that it's a CES production function. So like we did, we're going to say this is given by the same formula that we just learned, differential of K over L, which I've written on top, then over MRTS, differential of MRTS, and MRTS on top, and K over L. But we know that we're going to employ that trick. So let's go on first of all, work on MRTS, which is just marginal product of labor over marginal product of capital. Then marginal product of labor is just equal to the differential of the production function with respect to L, which is equal to, we drop the power 1 over P, then we copy the things inside just as they are. We say 1 minus M LP close the brackets, we have the power reduced by 1, like that, and we differentiate L in here. So L, when we differentiate it by chain law, we drop the power, and we'll have 1 minus A, then we'll have L, the power P drops by 1, like that. And we can see that P and P cancels, so we just remain with this expression as our marginal product. This one I'm just copying. I'm just copying the exact things. Let's go on and get now the marginal product of capital differentiating the production function this time around with respect to K. So as usual, we drop the power and copy the things inside as they are. Then the power drops by 1, like that. So now if we differentiate there, the K, which is here, even here, yeah. Yeah, you can see it's even here as well. So we drop the power, P will be dropped, then we'll have A, K, then we'll have P minus 1. I know it's not clear. I'll just copy the things here, but we can see that P and P is cancelling, so we'll have AK, P, at least from this one I've started from a a very good point. So we will have 1 p minus 1, then we have ak the power p minus 1. So this can be seen now. Yeah. So this power is just to the k, as well as here the power is just to the l, not the constants. So what we do next is just to find the MRGS now. That is just dividing these two expressions. So we will have ak p 1 minus a l 1 over p 1 minus 1, I mean a. I'm supposed to write 1 minus a of l p minus 1 like that. Then we will have everything over a kp plus 1 minus a l 1 over p minus 1, then ak p minus 1 like that, the one we had here. So we can notice in here that this power root of the expression is cancelling with that, and we're just remaining with MRTS equal to 1 minus a l p minus 1 divided by a k p minus 1 like that. So we just need to go further a little bit to simplify that one, considering the things that we have in our formula. So in the formula, you can notice that once again we have k over l. So I'm just clearing this. So we can notice that, as I've just said, we have k over l. Then in here we have l. I also need to extend this here. So l over k, which is different. So we need to swap those. But before we swap them, let's just factorize powers first of all. So we will have 1 minus a over a. Then we will have l here over k. Then the powers is p minus 1. So like we did from the previous example, we are going to, what am I supposed to say? Well, we are going to interchange this. Yeah. So interchanging that, that means we are multiplying this power by a negative. So we will have L over, I mean, it's supposed to be, because we're interchanging this time around. So we have K over L, then the power will be 1 minus P, like that. So this will be our MRTS, this expression. Yeah. But in the formula, you can notice again that we have this. So we need to make this the subject again. So how do we do that? Let me just write it from here, from this creative space we have. But I think it will confuse a lot. Let me just clear this as well. So from that, before we even go further, from here we can say over 1, then we cross and multiply so that that a goes the other way around, so that we have a m RTS like that is equal to 1 minus a. Then we will have k over l. Then we will have 1 minus b like that. So we can divide that both sides. Divide that both sides like that, so that we remain with a. This is just a constant. So we pull it out somewhere. So it will be something like this, like that. Then we'll remain with k over l, 1 minus b. We're interested in making this the subject, so we need to get rid of the power. So we're going to say 1 over 1 minus b, multiplying by the reciprocal of that so that it cancels. We remain with k over l. I'm just interchanging, writing the k on the other hand, then this one on the other side as well. So it will be a 1 and start. So this thing will be raised to 1 over 1 minus b, like that. Then we'll have MRGS raised to 1 minus b as well. like that. So this is our expression now for K over L. So we have all what we want to satisfy this uh, function, or rather the formula. But the only thing left is just, you notice this one. And it'll be a little bit confusing for some, considering these letters. So what we need to do is to employ a very simple trick. So what we're going to say is, like we did in the previous one, we are going to let this one be y, then also this one, because this one is just a constant, it can cancel. So we are going to say, let this one be a, then this will be just x, like we did. So this expression will be just y, a, because we've read this one to be a, then we'll have x, then we'll have 1 minus b, like that. So it will be very easy for one to get, this, the y over the x multiplied by x over y. So it will be very easy to get the y over the x from this expression. So if you differentiate this, you drop the power of x, you'll have 1 minus b, we'll have a here, then x, 1 minus b minus 1, the power drops by 1, and multiply by x there. And here, we're just going to replace the y value here because we want everything to be in terms of x for easy computation. So we will have a x 1 minus b, like so. So we can notice that this a and that a goes, we remain with 1 minus b, constant. Then this multiplied by this will just be x 1 minus b power. Then this will divide by this. So we divide by x 1 minus b, like that. Then we can notice that the things in the bracket is just a 1 because they are the same, and when they divide, it's just a 1. So we'll remain with 1 minus b, just like so. So this is proving as well that it's a CES production function. So that's it for this video, guys. Hoping to see you in the next video.